In lesson 5, we're going to look at operations with functions. So addition, subtraction, multiplication, and division of functions. So here's the different notation for operations. So basically, if you have two functions, f and g, that have the same domain, then we can use these notations to represent operations. So f plus g of x basically just means add function f to function g. F minus g of x means f of x minus g of x. F times g of x means to multiply the two functions. And f divided by g of x means that you can just separate it into the division of the two individual functions. One thing to note is that in the end, the denominator cannot equal 0 because, if you remember, for domain, the denominator cannot equal 0 when you end up with a fraction. So let's look at some examples of these. So in example 1, we have two functions, f of x and g of x, and we're going to go through and we're going to do the 4 different operations. So I'm going to number these 1, 2, 3, and 4. So starting with number 1, we have f plus g, which really means f plus g of x. So we're going to add, this is the same thing as saying f of x plus g of x, which means I'm going to take function f of x, so 4x squared plus 3x plus 2, and to that I'm going to add g of x, so this function here, so plus 2x squared minus 5x minus 6, and I just want to simplify this. So basically all it means is combine like terms. So if you look, we have a 4x squared and a 2x squared. So together we add the coefficients, we get 6, and we keep the x squared. Then we have a 3x and a negative 5x. So again, 3 minus 5 is going to give me negative 2. Keep the x. And then the numbers at the end. So we get negative 4. So this is my function f plus g of x. It is a result after adding the two individual functions. And then the only other thing I want to do with this is say, okay, well, what's the domain of my final function, or f plus g of x? So the domain, if you look, we started with two polynomials, or two quadratics, and we ended with a quadratic. So there's no restrictions, so it's just going to be all real numbers. So negative infinity to positive infinity. Remember, when we're talking about domain, we're looking at those, are there square roots, are there denominators, or do we have logs, or do we have piecewise functions? But remember, we haven't seen piecewise or logs yet. So we don't really need to worry about those two things. So really, we can say, okay, well, the answer for domain is going to be all real numbers unless you see a fraction or a square root. So let's look at the next one. The next one is going to be f minus g. So we're going to subtract our two functions. So we're going to take f of x, and then we're going to subtract g of x from that. So again, I'm going to start by just basically rewriting f of x. So 4x squared plus 3x plus 2. And this time, when I subtract the function, when I added, I didn't worry about parentheses, but when you subtract, you need to make sure that you put parentheses because you're going to end up switching all of the signs or distributing that negative. So it's important that you use parentheses for subtraction. So basically, I'm just going to rewrite this. So I have 4x squared plus 3x plus 2, then distribute, so minus 2x squared, negative times a negative, so plus 5x, negative times negative, plus 6. And now we can go ahead and simplify. So 4x minus 2x squared is going to give me 2x squared. 3x plus 5x is going to give me plus 8x. 2 plus 6 is going to give me plus 8. And from there, we can go ahead and just make sure we put our notation because this is a function, so it should be expressed as an equation. So I'm going to just say f of g of x equals this expression that I got out. And then the last thing is we're going to talk about the domain. So we started with the polynomial, we subtracted off a polynomial, we're left with the polynomial. No restrictions, so negative infinity to positive infinity. The next one we have multiplication. So we have f times g of x, which again basically means multiply the two functions. So I'm going to use parentheses because we're multiplying this entire f of x times this entire g of x. So if you look, we have a trinomial times a trinomial, and if you remember back a while ago, we talked about how to multiply polynomials, and we use the box to help us, or the grid. So I have a 3 by 3, so I'm going to put 4x squared plus 3x plus 2. Up across the top, I have 2x squared minus 5x minus 6. And then you multiply to fill the boxes. So 4x squared times 2x squared is going to be 8x to the fourth. 3x times 2x squared is 6x to the third. 4x squared. Negative 20x to the third. Because remember, you're adding the exponents when you multiply. So we have negative 15x squared, negative 10x, negative 24x squared, negative 18x, and negative 12. So then we look for, in our diagonals, look for those like terms. So I have like terms here, and like terms in that diagonal. So when you go to write your final answer, we have 8x to the fourth. If you combine these, you're going to get negative 14 x to the third. Combine this diagonal here, we get negative 35 x squared. Combine this, negative 28x, and negative 12 at the end. So there's our function, and again, the domain of this function, we multiplied a polynomial times polynomial. We ended with the polynomial, so no restrictions, so negative infinity to positive infinity. And then the last one here, we have division. So we have f over g of x. So f of x, we have 4x squared plus 3x plus 2 over g of x, 2x squared minus 5x minus 6. And if we could, in order to reduce this, what we would do is we would factor the top and we would factor the bottom, and we'd see if we have any common factors. But I've already tried this and it doesn't factor. So to check to see if it actually does factor, in this case you'd have to do the AC slide where you multiply the 4 and the 2, you get 8. You say what multiplies 8 and adds 3. There's nothing that works. So that's why I'm just going to leave my final answer like this. When you look at this one though, you should know that there's a domain restriction. So the domain of this final answer is not going to be negative infinity to positive infinity because we can't have this equaling 0. So because we can't have that equaling 0, when we go to find the domain, we're going to set that denominator not equal to 0. So again, you can try to factor this. 2 times negative 6 would give me negative 12. Trying to find two numbers that multiply to negative 12 but add to negative 5 isn't going to work. So that tells me it's not factorable. So what I'm going to do is I'm going to use the quadratic formula. So negative b plus or minus b squared minus 4ac all over 2a. And what I'm going to do when I actually go to solve this is I'm going to do x not equal to these numbers because remember it's not equal. So I have negative b, so negative 5 is b, plus or minus b squared, so negative 5 squared, minus 4a, which is 2, c is negative 6, all over 2 times 2 for a. So x does not equal. So we have 5 plus or minus, when you simplify all of this under the square root, you get 73 all over 4. So the domain is all real numbers except for 5 plus radical 73 and over 4 and 5 minus radical 73 over 4. So the domain, all real numbers except x equals 5 plus or minus 73 over 4. Now, to write that in interval notation, you imagine a number line where you have two of these. So you have 5 plus radical 73 over 4 and 5 minus radical 73 over 4. So you'd have 3 sections on your number line. So basically it's going to go from negative infinity to 5 minus. So that's going to be the smaller one. Union. And then in between the minus and 5 plus radical 73 over 4. Union. And then you pick back up 5 radical 73 over 4 to infinity. So again, if you picture it on a number line, you would have 2 of these points plotted, and you'd have the negative 5 minus radical 73 over 4, and 5, these should be open circles, it doesn't look open, and 5 plus radical 73 over 4, and those are the only numbers you can't have, so you have everything else between them. So you have these 3 sections, or these 3 intervals for your domain. So that one's definitely the trickiest one that you've seen, but that's probably as hard as it gets. So one last thing in this video is to look at this example 2 and basically take the functions that we used in example 1, I should say, and so this is going to be f of g, not f of h, and what we're going to do is we're going to evaluate those functions. So when we look, number 1, f plus g of 2, basically we already know from the previous example that f plus g of x is equal to 6x squared minus 2x minus 4. I just got that from the previous example. So in order to find f plus g of 2, all that means is input 2 into that function. So essentially you're just plugging in 2. And then evaluate all of that and you get 16. So that's all you're doing for these. It's just evaluating. Now, if you didn't know the f plus g of x, you could do what we just did in the previous example where you find it, you simplify it, or you could just take that 2 and plug it in to this whole entire thing. It would just be more evaluating in your calculator, but it saves you from having to simplify first. So it doesn't really matter how you do it if you find the simplification of the function first, or if you just plug the 2 into this entire thing. So let's look at the next one. We have f times g. So f times g of x we already found on the previous page, so let me just copy that one down. So 8x to the 4th minus 14x to the 3rd minus 35x squared minus 28x minus 12. Again, if you really wanted to, if you didn't want to multiply and get your product, you could just leave it as f of x times g of x and plug that -1 right into f of x times g of x. So you don't have to simplify it first for these ones. It's just, since we've already done it, it's easier to use the simplified ones. So basically this is the exact same thing. You're going to take -1 and you're going to input it into the new function f times g. So we're going to plug it in. Make sure you have parentheses, especially when you have negative numbers when you plug in. So I'm just substituting -1 in for every x, or I'm inputting it into my function, and then I simplify it and I get 3. And then the same thing for the next one, for number 3, except for now we're going to input 0. So we're going to go ahead and we're going to take basically the function right up here, and we're going to input 0 into that function. So 0 is going into the function, so it's going to be 8 times 0 to the fourth minus 14 times 0 to the third minus 35 times 0 to the second minus 28 times 0 minus 12. And if you look, these are all going to become 0 because 0 times anything is 0. So I'm just going to be left with the minus 12. And then the last one we have g divided by f. So if you look at this function, this is like saying g of x divided by f of x. So we didn't do this one on the previous page. We did it as f of x divided by g of x. So this is going to be a different function. So it's going to be g of x over 4x squared plus 3x plus 2 over f of x. And we should say where f of x does not equal 0, or let's just say at where 4x plus 3x plus 2 does not equal 0, just to define it as, remember, domain of this can't equal 0. So instead of going through and finding the domain of this, let's just leave it as where this can't equal 0 when we write our function. So then when we go to evaluate it, we're trying to find g over f of 5. So I'm going to input 5 into this function. So we have 2 times 5 squared minus 5 times 5 minus 6 over 4 times 5 squared plus 3 times 5 plus 2. And simplify the top, you get 19. Simplify the bottom, you get 117. And you can just leave your answer as a fraction.